Today I'm working on my 2007 Toyota Prius. Took it on a trip last weekend, and the red triangle with the exclamation mark came on the dash. It said problem detected on the screen here. Checked the codes. P0A94 was the code. Has something to do with the inverter or the transaxle. So I opened up TechStream to check this out. I did reset the code on the car, but here's the saved file. So you can see we've got P0A94 DC converter performance, current and in history. If we double click on that, it will bring up the freeze frame data. And here is our freeze frame data. Nothing about it stands out to me. I think sometimes if there is abnormal data, it will be highlighted automatically by the program, and nothing was highlighted. You can see that it was pretty hot outside, and judging by the fact that code 553, which is the subcode, does potentially indicate an overheating condition. The hot temperature outside may be relevant. The next step is we are going to walk through the troubleshooting. Here we go, P0A94. I saved these as a PDF document so we can look at them. And we can see here P0A94 with the subcode of 553. The boost converter has a circuit malfunction, internal short or overheats. Potential trouble areas: wire harness or connector, inverter cooling system, water pump or motor assembly, cooling fan motor, number 2 cooling fan motor, HV transaxle assembly, hybrid vehicle motor, hybrid vehicle generator, HV control ECU, inverter with converter assembly. So in these steps down below, it basically has you start at the top and work through those trouble areas to check them off. So we are just going to walk down through this, and I'll show you what I have worked on already. So we have read the output DTC. None of these other codes have shown up. First step is check quantity of HV coolant. We can look in here, see that the coolant looks pretty dang good. Next step is check coolant hoses. We're supposed to check that the hoses are not clogged or bent. So we can see hose right here. We can squeeze that and see the air moving through there. Can see the hose going down here, and does not appear that this hose is bent or clogged in any way, at least as far as I can tell. All right, next step. So then the way you look at this tree is, okay, so if it's not good, you correct to normal condition. It looks like it's all good, so we go to the next step. Check condition of water pump connector, looseness and port contact. So interestingly enough, over here on this side, you can see that's the connector right there. And I'll show you here. It pops off way too easy because the retainer is bad. So I suppose that's a possibility. However, when you turn the car on, you can see coolant bubbling right there. Check water pump with motor assembly, turn the ignition switch on, check the operation of the water pump. If it's okay if the coolant is sloshing in there, and I'll show you real quick what we get. So we can see the coolant sloshing in there. Supposed to check the connection of the cooling fan motor connector. looked down here, and you can see one plug right there. There's another one farther down. Both of those plugs seem fine. Furthermore, when I was testing this the other day, after the engine was warm, both of these cooling fans were running just fine. And, you know, we're supposed to inspect the fan motors, assuming that they're running just fine even when the engine was very hot. I don't think there's a problem. So then our next step, which I haven't done yet, is check the connection condition of the hybrid vehicle control ECU connector. So we need to find where this is. Okay, so then at the beginning of the hybrid vehicle control section, we can find the diagram that shows where everything is located. And the hybrid vehicle control ECU is behind the glove box. So we're going to go check that out. I can't blame this on Jiffy Lube. So here is the hybrid control ECU. So I believe it's that one on the far right. Okay, so I just removed and reseated all of these guys. Did not find anything concerning there. Everything seemed connected well. So then our next step, check connection condition of inverter connector, looseness and port contact. We're supposed to wear insulated gloves. Turn the ignition off, remove the service grip plug, and removing the inverter cover, checking the connection. So yeah, we're gonna go ahead and do that, see what happens. Okay, I just removed the cover, pulled the tray out of here. We're gonna remove the service plug. To do that, you just pull up, pop it out. There we go. And then the next step is to remove the inverter cover. And then under here we just have a bunch of 10mm sockets, including that guy there, that come off really simply. And then there's just one plug here for this that comes off, and this comes out. Then the last thing here is just these two bolts here that hold that relay box in there, and then we'll pop out a few little connectors that hold this wiring loom on there. All right, and it's out. All we need to do is pop the cover off with a 10mm socket, I believe. To keep the inside of this clean, I realize I should probably blow this off, so Alright, just gonna wipe this down a little bit as well. Alright, and the last one here, it's a T30. Let's pop this off here. Got it. Okay. Connection between I9 and I10 inverter connectors. Okay, let's check this guy. That looks good. This little guy here. Let's see if I can get that with these gloves. There we go. Looks okay to me. We're going to plug that back in. Okay. We just finished up looking through the connectors, making sure they're connected correctly in both the to both the ECU and the inverter on the inside of that. So the next step was to confirm information exclusive info 4. I was having trouble finding what this meant. In text stream, it's set because in these instructions, it says to select the item that has INF code 553 and press enter, but nothing was displaying. So you can see, like, if I select 553 and hit enter, nothing happens. Double clicking on that doesn't do anything. So what I figured out is what you actually do is go down here to where it says all data, and instead click on information 1, and then over here we have our exclusive information, and we're looking at exclusive information 4 right there. We have a value of -127. So we go back to our diagnostic tree and we look at this chart, the result, and -127, and just note that there are negative and positive values. So there's a positive value, but the -127 means to proceed to step A. So step A, inspect hybrid vehicle motor assembly. So we once again are supposed to remove the inverter cover, disconnect the inverter cable, and then we're supposed to do some tests there. So we're going to go and do that. Okay, so following the instructions here, we have opened and removed these connections that go to the motor. That apparently is the AC connection for the motor. This engine is cool. It's been sitting overnight. So we are going to go ahead and perform these tests here. So we're going to start with U to V, which is the ones on the firewall side. So we're going to connect there. Got my multimeter set up here. Going to connect to there. And what are we looking for here? We were looking at so I just realized this thing doesn't really measure milliohms. The lowest it'll go is kind of like a 200 ohm measurement, and right now we are measuring 0.2 ohms, somewhere between 0.1 and 0.2 theoretically, which would indicate this, you know, could be accurate, maybe. I'll need to correct for the temperature. And I get basically the same alternating between 0.1 and 0.2 with all of the tests on here. So we are going to go over and do this calculation for the resistance. Okay, so realize to measure milliohms, I'm going to need to do some work to create a circuit that will measure milliohms. In the meantime, there are some mega ohm readings that I will be able to take, and so I'm going to do all those first. So we've got this piece sitting right here, and we've got U, V, W. These ones are in milliohms, so we're going to skip that for now. We are going to do this one, which is to the body ground. So we're going to just clip this guy to the ground right there. And I believe all of these should just be 10 mega ohms or higher. So let's see what we got. We're going to go to the first one. Got nothing there. Nothing there. And nothing there. So these guys seem to pass just fine. We are going to be testing some voltages at this plug right here. So I'm just reconnecting these. I figured I'm going to do this test before I mess with trying to figure out milliohms. I think this will be easier. Alright, so we have the car on now. Those lights are on because the safety plug is removed. I've got TechStream pulled up here. We are going to go into the hybrid control ECU. And then the instructions in here are saying to do the active test inverter stop. So we're going to active test, and we want to do forcible stop of inverter drive. Sounds about right. Probably should have read what that was saying. And then let's see if this works. Okay. Okay guys, this is the most exciting thing I've had happen all day. So we have, if we test, so I've got these back probed here with pins. So we can go here. We got 14 volts. And this one has 14 as well. Oops, so that one has 14. Then once we get to this guy here, we've got half a volt is all this is giving us, which that seems problematic. Hopefully that's the problem there. We'll continue through this test, I suppose. So we're supposed to do GUU, GVU, and GWU. So we basically go work our way across this from here now. We're gonna go there. Okay, got voltage there. That one's good. And I believe this is the last one here. Oh, okay. So that one also appears to have no voltage. And so that was GWU, and I believe MWU are the two that have no voltage. Which seems problematic, and so that hopefully is the problem there. That seems like those are correlated, so I think we've got a bad inverter. Okay, so this next step requires us to unplug that plug and do the same test. So I have the plug unplugged, and I just tested across here to my multimeter that's hooked to the ground pin, and we got the exact same results. And what that indicates now is if it's not good, that we replace the inverter with converter assembly. If it was okay, we would have replaced the vehicle hybrid control ECU, which is that one that's behind the glove box there. But this verifies bad inverter. So we're gonna go get one now. All right, so I wanna do an update on this inverter. While I was diagnosing this inverter, you need to take some measurements by back probing this connector here with it plugged in. You take a reading off the ground, which is the top pin on this far side, and then 6 pins in the middle here you measure. So I just want to make sure nobody else makes this mistake. I looked at the pinout on the factory service manual and just began counting 1, 2, 3, 4, 5, 6, 7, and counted from one side to the other, and then stuck my pins in the back of here to back probe, took my measurements, and several of the pins came back negative, and I thought, oh, that's interesting, but yeah, I guess it confirms that it was bad. But then that kind of kept haunting me, and I kept thinking like, well, okay, was the pin out backwards? Was I looking, was the ground actually over here? Maybe that green one was the ground and the pins were, and I was like, well, no, I don't think so. And then, I start looking at other pinouts that show all of the labels for every wire, and realize that on this side, there are 2 wires that don't have any labels on them, or 2 pins at least. And so then I kind of start thinking about it and trying to figure things out, and okay, then I realize it. Oh, there are 2 unused pins on this side. I mean, technically like 1 space, but I don't know if you can see. Right there. Unused pin. So when you count, you start with the unused pin and go 1. Then the green one is number 2, purple 3, 4, 5, 6. So the bummer is my measurements were offset by 1, which is why I got the measurements that I did. That's the bad news. The good news is because of the way that the troubleshooting was laid out, even if all of these pins tested good, the next step was to replace the inverter. So I think replacing this inverter was the right choice. And I since took a look at this inverter, and we noticed that this whole piece in here is cracked. You can see this is cracked. This is actually bent in. You can see the gap here is much closer than the gap here. I think that's supposed to be basically the same all the way across, although not positive, but I do know putting the cover on, you can see this is like a 1/4 inch in right here, as well as right here. So this whole section is bent in about a 1/4 inch on this side. This piece out here was broken off. Someone had glued it back on at some point, and it fell off when I was removing the inverter. So I think replacing this inverter was probably the right call. Even if I messed up on the test. It's embarrassing and frustrating that I messed up on the test, but I just wanted to share this with you so you know that you don't make that same mistake. And then, you know, the reality is we should have completed the test on the motors, the motor and the generator, before continuing on to this, because the whole diagnostic tree is basically the process of elimination. So we really needed to eliminate the generator and motor as the culprit before we moved on to the inverter. Those milliohm readings would have been more difficult to take. Okay, well, just went out to pick picked up another inverter. So now I'm pulling this inverter, and I've got these 2 mounts in the front pulled. There's just one back here that I think needs to come off, and that might be the last one. Let's see. There we go. Okay, so I just drained that reservoir with a turkey baster since the fluid is really good in there. I have a little bit of extra fluid, but I'd like to reuse most of it if possible. And then I am just going to pinch off the 2 coolant lines here. I have these 2 gray plugs removed, and the mount is removed back there as well. Okay, so I removed those 2 hoses and lost just about no fluid. It was really quite successful. There is one more hose here. I'm going to pinch this one off. This is the bleeder hose. So I'm going to pinch this one off and then remove the inverter, put the new one in. Okay, so I've got the new inverter installed. I just reconnected all these wires. I re-added the coolant that I drained out of this, out of the previous inverter, and then added a little extra. You want to use the pink coolant. And now what I'm doing is bleeding it. The bleeding process is simply to add coolant, open the bleeder, and add coolant until the level in the hose matches the fill line on there, the full line. And then just to run the pump by turning the vehicle to the on position, stop it, open the bleeder, let air out, and just continue that until it's air free. So, I'm getting a better understanding for at least this diagnostic tree. I don't know. They're probably not all the same. I think when I was looking at kind of the testing we were doing on this, I took this test as kind of like a positive, like a test showing that the inverter was bad, when in reality, it was just showing that the inverter was getting power on these pins. I believe that's kind of what the test was doing, and not kind of like what I was assuming was, showing that something was going bad in the inverter. So kind of the if we were to break down the process, they're saying, okay, so the most likely thing to be bad on this would be a clog in the cooling system. So assuming that the cooling system was functioning correctly, being that we could see this coolant moving, we move to the next step, which is to test the motor and generator. And, so we tested the motor and the generator. We tested for a short to ground, didn't find anything there. We did not test the milliohm readings in the coils on the motors, which would have been kind of, the wisest thing to do. So that would have been the next step, because basically what we were attempting to do is eliminate those as the cause. And if we can eliminate the motor as the cause, then that's when you move on to this. And that's why they say basically, okay, as long, now that we know it's not the motor, as long as this thing is getting power, we can assume that it's this. And if this isn't getting power, then I believe it's the ECU. And then we move on and replace the ECU, because the ECU is supposed to be giving power to this or something. So that's kind of my rant on it.